So let's say I'm filling the water and the bunnies are so thirsty, they throw themselves over the trough and start drinking, right? They love that they're getting fresh water in there. So if the bunnies are super thirsty and they're drinking the water, as the trough is being filled at a rate, so I'm giving you a rate here, drinking rate here, right? This is how fast they're drinking. At t is equal to 1 minute, the height of the water in the trough is 2 inches. How fast is the water changing at t is equal to 1 minute? Assuming that the trough is not empty when Mrs. Pointer starts adding the water. So then I need to figure out how much the water is changing to answer this question. Essentially, it is the same question as part A, where we were asking, is the height of the water, how fast is the water changing? That's what I meant. How fast is the height? I should add that here, the height. That's what I want to know, of the water changing at t is equal to 1. That's really what I wanted to know. All right, so if I'm asking you how fast the height of the water is changing, the only thing that changes is how the volume is affected, right? So it's really the rate going in as opposed to going out, because as water's coming in, water's also coming out. So I need to figure out what the rate out is, essentially, when t is equal to 1. So I'm taking d of 1 is equal to negative 1 squared plus 4 times 1, which is positive 3. So that means then the volume, dv dt, we have a rate in and a rate out. The rate in at t is equal to 1 is going to be 2, but the rate out is going to be 3. So that's going to be negative 1. So now my volume is decreasing at that time. So then we need to look at what was the volume in the first place. It was 1/2 base times height times the length of the trough, which was 10. B is equal to 5BH. And we also discovered that we could replace the B by 3H over 4. So that's going to give me 3H over 4 times H. So the volume is now 15 4H squared. And then we take the derivative. So it just adds a little extra step to it. D dt of both sides, d dt of 15 fourths h squared. So that's going to give me, I got to go up here, dv dt is equal to 15/2 h dh dt. But now when h is equal to 2, or in our case, when t, it's really asking you when t is equal to 1, then you're told h is equal to 2. I know that dv dt is equal to negative 1. So then it's negative 1 is equal to 15 over 2, h is 2, dh dt. So those little bunnies are actually drinking the water faster than I can fill it. So dh dt is then equal to negative 1 over 15, and then it's inches per minute. So therefore, the height of the water, or you know what, I think I would just rewrite it prettier. The level of the water in the trough is decreasing, oy, oy, oy. Let's try that again. Decreasing at a rate of, and because I'm using the word decreasing, I'm just gonna write 1/15 inches per minute when t is equal to 1 minute. And that's it.